everyone, welcome back to my channel. I hope you liked the first session on basic math for JEE Mains. Let us continue with our second session, starting with solving few problems, continuing from the previous session that we did. So we have a log problem over here. Now we need to consider that applying log, first of all, if we have some equation and if we have to apply log on both the sides, the expression on both the sides needs to be positive. Now over here you can see that when I am trying to apply, first I have to make sure whether they are positive or not. Now x minus 1 mod is always going to be positive and to its power still positive. That means this side is also has to be positive because it's an equation, not an inequality. When this is positive, we have to take in consideration that this is an odd power. That means what? The base has to be even, in the sense that the base has to be positive, because positive to the power odd only will give you positive, or else it's going to be negative. And thereby we get this condition that x minus 1 whole power 7 is positive, therefore x minus 1 has to be positive. Now let us continue taking log on both the sides with base 3. When we take log on both the sides with base 3, I can see that this term will come common, and this is the another factor that we have. Now these are the two factors, that means either this is the 0 or this is 0. Solving this is pretty easy. 3 power 0 is equal to x minus 3, because we already know that. Let me mention that over here. We already know that log x base a, b is equal to a power b as x. And another inequality equation I can see that I can convert it into an quadratic equation. First of all, for that I need to make sure the base is same. Now we have already learned how to make the base same. Coming from this step to this step, we did just one property of log, that is log x power m is m log x. We applied here as well as over here. After that I am converting this to base 3, which we have already learned in our previous sessions. You can go through that. After that, take t as log x base 3, thereby solving the equation you will get this. Now our requirement is to get the value of x, so log x base 3 is this. Now again applying the property, we will get these two values of x. Now we need to go back to the roots and see whether it is satisfying the initial condition that we got from the equation. And we got that x minus 1 has to be positive, but at x is equal to 1 by under root 3, I will get x minus 1 as negative, and thereby I am eliminating this answer, that is rejecting. So we have two answers over here, x has 2 and x has 81. Now let us start with a new topic, that is graph, which is very interesting and it's easy to predict just by knowing some rules. So for today's we will just focus on solving graphs with mod. So if you first of all, for solving this, you need to know the graph of f of x. Any function given to you, you should be able to predict using derivatives and calculus topic, trigonometry topic, all this combined. You should be able to predict the graph, and thereby we can proceed further. Now I am trying to look for the graph of mod of x. So for this we have already learned concepts of domain and range. Now you have to apply that and predict what will be the domain and range. The one thing that we can predict is mod x is given as the function. That means what? The value, that is the range, is always going to be greater than or equal to 0. That means what? The graph is going to lie above x axis. So what we are going to do here is, the first step is to draw the graph. So we have taken here sin x. Now I need mod sin x. The next step is to just reflect the graph that is on the negative part of x axis to the positive about x axis. That means you are just flipping it upwards. So this part will go to this, and this will become this part, and this is the graph that you will end up with. Let me repeat once again. Draw the graph and then reflect the negative part of the graph about x axis. The next one is, instead of taking mod of x, I am replacing x by mod x. And when I do this, what happens is x is replaced by mod x. In this case, one thing that we need to observe is f of 2 and f of mod minus 2. They both will be having the same value. So what if I just get the value of f of 2 and the same value I will put for f of minus 2? That also works. That means what I am going to do is I will just consider the value of the function for the positive x axis. And then if I reflect it about y axis, I will end up with the same graph as this, and each value at x and minus x will be same. Let us go through this. The first thing you are supposed to do is draw the graph at y is equal, draw the graph for all x that's possible. Next is erase the part of the function to the left of y axis, that means this part, because I know that all the values will be same as on the right side. Now reflect the remaining part about y axis, and this is what you will end up with. Now let us see one example. So you have y is equal to x square minus 5x plus 6, very well squared equation. We are getting two real roots, we can plot it. So we will do two things. First thing is f of x, that is mod of f of x. We have already learned, just reflect the graph that is below x axis about x axis upwards. So this is what we will get. And another one is f of mod x. So we already know that, draw the graph, erase whatever is on this side and then reflect it about y axis. The next one is, now for this graph I need mod. So it is actually mod of f of mod x. Now for this what we know is, take the graph, rub whatever is there on the bottom and reflect that about x axis upwards. So this is what we get. Now coming to exponential inequality, which is very easy and interesting. For this I hope all of you are able to process what is increasing and decreasing function. Now coming to exponential inequality, we have two categories, that is when a is greater than 1, another one is when a lies between 0 to 1. When a is greater than 1, a of x function is an increasing function which looks like this. And it is anyway going to be a positive function because a is greater than 1, and a positive number to the power anything will end up with positive only. Similarly, when a lies between 0 to 1, still being positive, a power x is a positive function, but it is a decreasing function. So what observation we can make is, 1 by 2 lies between 0 to 1. So if 1 by 2 whole power x is greater than 1 by 2 whole power y, that means x is less than y. Through an example also we can understand, half to the power 1 is greater than half to the power 2. But when we compare this inequality, let's say this is x, this is y, we say what? Y is greater than x, isn't it? Because it's a decreasing function. Coming to the next one, where 3 is greater than 1. What we are supposed to do in this is, if 3 power x is greater than 3 power y, then x is greater than y. Simple. Now let us try to solve few problems based on this. So you have 2 power x greater than 5. Now I am going to take log on both the sides. First of all, 2 is greater than 1. It's an increasing function. So when I take log on both the sides, x will come to the bottom. So log 2 base 2 is anyway 1. And this is the inequality that you will get. Pretty simple. Next one over here is, you have 1 by 2 which lies between 0 to 1, and thereby 1 by 2 power x is a decreasing function. Now what I am trying to do is, I am trying to make base same on both the sides of the inequality. So 1 can be written as 1 by 2 whole power 0. Sorry for this color that I have used over here, it's not that clear. Now what I am trying to do is, I am trying to compare the power. Now I know that half is a decreasing function. So with this inequality, the relation between the exponent is going to be this. Thereby solving this inequality, I will get this as the value of x, that means x lies between this. One more thing that we will get from this is, this has to be greater than equal to 0 because of the condition that we have. Now, if you look at this, I didn't consider equal to 0 because if this is 0, then log 0 base 3 is 0, half to the power 0 is 1, but this is only greater than, not equal to. That's why I have removed the equal to sign. And when you solve this, this is the inequality that you will get. But at the end, we are supposed to combine both of these. And in previous session, we have done a lot of problems where we have combined. So you can go through that. After combining, this is the value of x that we will get. Let's do one more problem on this. Now, we already know the definition of mod, right? That is mod x, let me mention it over here. Mod x is equal to x when x is greater than or equal to 0 and minus x when x is less than 0. And that's what I am doing here. I am trying to divide into two cases. The first case is when this is positive. When this is positive, I will solve an inequality and this is what we will get for x. Now, let me substitute this back in the inequality. So, when I substitute it back, on solving, I will get x greater than 2. Now, you are supposed to combine both of that because they both come under the same case and this is what I will get. The next case is considering mod x is minus x. That means x less than 0. Keep in mind the x that I am considering is whatever is inside mod. Now, when this part is less than 0, on solving you will get one value of x, that means an interval, I would say. And next thing is you substitute it back in the inequality and you will get this. On combining these two, this is what you get. And at the end, you are supposed to combine this with this. And this is what we will get at the end. Right? We just have 2 to 3 problems left. So let us continue without any break. Right? Yeah, this is one observation that we have, that is mod a plus b is equal to mod a plus mod b only when the product of ab is greater than or equal to 0. So here you can see an example as well, that means justification. You know that AB is greater than or equal to 0 only when either both are positive or both are negative. So here is an example. If one is positive, one is negative, this will not work. Right? Now let's come and solve this problem. If you look at this problem, there are actually 3 ways. One is graphically. If you are good at drawing, you can draw very well. Another one would be considering this as a function, that is, this is equal to x minus 2 when x greater than or equal to 2 and minus x of x minus 2 when x less than or equal to 2. Same with this, and then making like 4-5 cases will come. Right? Without that, what we can do is, I do observe that when I do something with 5 or 2 operation, I can get 3. That is 5 minus 2 is actually 3. So, but when I add these two, I am getting actually 2x minus 7. What if I just change it, which I can do in mod, right? Mod x is equal to minus x. So I wrote it as 5 minus x, and when I am adding these two, I am getting actually 3. So this is the observation that we made, that mod x plus mod b is equal to this only when the product of that is greater than or equal to 0, and on solving I get this. Pretty easy. Same over here if you look. When you add these two, you will get this. That means what? The product of this and this has to be greater than or equal to 0. So this is the inequality that we get. This value is equal to 0 only when x is equal to 0, and x square is anyway greater than or equal to 0, so I have to focus on the denominator. This is greater than 0 when x is greater than or equal to 1. Right? And one more thing here I think we are skipping is x cannot be 1. Right? So I need to put the other bracket over here, that is this bracket. X cannot be 1. Right? Because if x is 1, then 1 minus 1 is not defined over here. Okay? 0 is included because of x square. And one more thing that we need to keep in mind is, if x is 0, anyway the whole thing is 0, and x cannot be 1, rest everything will be satisfying. Okay? So I hope you understood what we learned in today's session, and you are able to follow continuing from the previous session. If not, please go through the first session that I did on basic math for JEE mains, and then come and watch the second session. It would be easy for you. So today we did few problems on log, basic math, then we learned graph for mod and FO for mod x and solve few problems on that, and then we learn exponential inequality as well. So we have one more session left on basic math for JEE mains, and in that I will be solving problems from JEE mains in advance, keeping in mind this topic, and after that we will be proceeding with our new topic. I hope you liked the session and you got some knowledge after watching this. Please like, share and subscribe. See you in my next session.